Hello dear students. Today we are going to study about Module 5 Geosynthetics and Reinforced Soil Structures. Let us first of all discuss about what is geosynthetics. About geosynthetics we will discuss what is geosynthetic, natural or artificial product that is used along with soil in geotechnical construction. Basically geosynthetic material, it may be a natural or artificial material. For example, natural we have coir, jute, hemp, etc. Artificially we have polymeric material or metallic material which are using along with the soil in geotechnical construction works. Why we are using geosynthetics? What is the advantage? Why actually we use the geosynthetic materials? Geosynthetics have entirely changed the way geotechnical engineering is practiced. Innovative solutions to solve difficult problems economically and expediently. So basically we use geosynthetic materials which has entirely changed the way geotechnical engineering has been practicing nowadays, which which helps us to solve the very difficult problems innovatively, also economically. It enables the use of local materials, which leads to the sustainable solutions. So use of local materials, for example local available soil, aggregate material, rocks, etc. It involves unskilled labor can be employed, unskilled labors, so it is not required highly skilled labors. So locally available unskilled labors we can use for the construction of geosynthetic structures. Installation does not require heavy machineries, again it is also one of the advantage here. So if you see in the first figure, if you see there, so there is a railway track very near to the slope area. So whenever there is a rainwater comes, there is soil erosion, you can see the gully formation. So if you apply the coir mat there along with the vegetation, which helps within a 2 season, you can see in the third picture there is a growth of vegetation which avoids the soil erosion there. So coir mat which promotes the vegetation growth to prevent the surface erosion there. So coir mat which holds the moisture long time, so as the coir decays it also provides the nutrients to the growth of the vegetation, which will be very advantage one. So if you see there, use of stone filled rope net gabions for shoreline stabilization at Swaminarayan Temple, Tithal, Gujarat. So offshore structure has been built by using rope net gabion there. So basically gabion is a mattress structure, so heavily filled with the rock materials. So offshore structures or offshore protection we are using geosynthetic material there. So irrigation canal lining by using grout filled geocells. So whenever there is a soft soil is there, water cannot flow easily. So to make it flow easily, so we are using the geocells which are filled with the grout materials. So also we are using geosynthetic materials in landfill construction very effectively and efficiently, also which will be very helpful in the avoiding the contamination of the groundwater and the environment. This is the landfill constructed at Visakhapatnam to contain Eurosite waste. So this is the first landfill that has been constructed by using geosynthetic materials. So flexible breakwater unit made of geosynthetics, beach sand filled bags in rope net gabions. Again the flexible breakwater which avoids the offshore erosion here. So protect the offshore we are using this type of structures. So reinforced soil. So basically reinforced soil is nothing but soil plus reinforcement. This is not new technology actually. This is has been we are using very from the long time. So anciently we are using tree branches, grass, reeds, straws, roots of vegetation, bamboo, tree trunks, etc. So if you see in rural areas now also we are using some bamboo along with mud for the construction of the houses, or to cross the marshy areas or small streams we are now also we are using tree branches or bamboo materials, etc. So in modern days we are using steel, polymeric, natural materials. As we know, soil is strong in compression and reinforcement is strong in tension. So the combined product which are will be very better, giving better engineering properties than the individual constituents. As we know, soil is very strong in compression but very weak in tension. So if we provide a reinforcement there, so which gives the very higher strength compared to the individual constituents. So the reinforced soil concept is very similar to the that of your reinforced concrete there. So we have different types of geosynthetic materials nowadays. So geotextiles, which are similar to our textile materials, many times we are using those as a separator or as a filter material. So geogrids, which are a grid pattern having aperture openings, which are effectively we are using as a reinforcement material. So geonet, we have a net like material, so which are we are using for the drainage purpose or to provide as a boulder, hold the boulders. So geomembranes, which are a mostly we are using for the water barrier structures, like in landfills, which are avoiding the flow of leachate there. So prefabricated vertical drains, PVDs, which are we are using to increase the consolidation process. Geosynthetic clay liner we have, which are using cushions, etc. So GSLs, which are a 3D confinement products, which are mostly we are using as a sub base reinforcement, also to protect the slope protection, slope stabilization product. So geocomposites, and the geocomposites are nothing but, so when there are one or two of the above materials combined to form the another materials, we call it as geocomposites. So geotextile properties, then we discuss about the properties of the geotextiles there. So we have physical properties, mechanical properties, hydraulic, endurance, and degradation properties. So physical properties, which indicates the uh, material of the geotextiles, like for example we have specific gravity, mass per unit area, what is the mass of the total material per unit area. Thickness we have, so thickness, then stiffness. So mechanical properties, which are nothing but our engineering properties of soil, so which decides the strength of the material. Hydraulic properties we have, so whenever the materials are used as a drainage material, filter material, hydraulic properties plays very important role there. Endurance properties are nothing but which avoids the, so the properties which helps us to avoid the installation damage. When while installing, there may be damage to the uh, geotextiles. Degradation is nothing but when the geotextile material or any geosynthetic material exposed to the hazardous environment, or they exposed to the like chemicals or offshore environment or sunlight, like that, so that should not degrade with time. So as discussed physical properties, we have specific gravity, mass per unit area, thickness, stiffness, which explains the material itself. So mechanical properties, the strength properties, we have compressibility, tensile strength of the geosynthetic material, seam strength, fatigue strength, burst strength, tearing strength, we have impact test also we have to conduct, punctures tests, friction behavior, pull out tests. All these are very important for the strength of the, to check the strength of the geotextile materials. Then we have hydraulic properties. Hydraulic properties, when we are using geotextile material as a drainage or as a filter material, so then we have to do the hydraulic properties check. So apparent opening size, we have cross plane permeability. Cross plane permeability, when we are using as a filter material, so along the it is through the geotextile material, that is the flow of the water through the geotextile material. In plane permeability is very important when we are using geotextiles as a drainage material. Gradient ratio test is also there, long term permeability test also we can do. So basically the functions, if you see what is the application or functions of the geotextiles material. So we are using geotextiles or geosynthetic material as a barrier for the fluid, as a drainage material, as a surface erosion control, for the filtration purpose, protection purpose, then reinforcement. As a reinforcement we are using as a separation function. So we will discuss one by one here. So if you see, the initially there is a slope is there, initial slope without reinforcement in a single lane. If you want to extend this road width, so you can provide the reinforcement and increase the slope angle, so you can get the extra road space. This is the application of the geosynthetic material as a reinforcement layer. So then we have separation function there. If you see, there is a separation. Geotextile separator has been applied between the subgrade soil and top aggregate layer. So if there is no separation layer is there, so what happens when there is a wheel movement? So aggregate will penetrate into the subgrade soil, that will be intermixing of the particles there. So there is a decrease in the subgrade soil strength. So if you provide a geotextile separator, so we can prevent the intermixing, prevent the piping action, strength of the aggregate is preserved there. So also we apply geotextiles or geosynthetic material as a filter layer. So what is the function of the filter there? So it avoids the flow of the fine soil particles when the water enters the pavement layer. So when there is a wheel movement is there, so there will be development of the pore water pressure. So the water will coming at the high pressure. So during that water moving, so the soil particles will retain there. If you provide a filter layer, so it allows only the water to flow out, it holds the fine soil particles, so it avoids the loss of fine particles, which we call it as a piping action. So it avoids the piping action and prevents the or preserves the strength of the subgrade soil. So surface erosion protection, you know that. So we have explained initially the requirement as a protection layer. Then we are also using as a drainage layer in a pavements. So you can see when we provide a drainage layer there, so when the water enters or ingress to the pavement layers, so it will easily move to along with the drainage layer, and it will leads to the side drains and it will be moving out. So as soon as the water falls onto the pavement, we have to remove the water there, so that we can prevent the or preserve the strength of the pavement. This is the end of the session. Thank you.